Hello everybody, today we will be looking at a 2017 AP Statistics free response question in preparation for the 2020 free response statistics exam on Friday, May 22nd, 2020. Remember that the exam will be formatted with 20 minutes to answer the first question, 5 minutes to submit, 15 minutes to submit to answer the second question, and 5 minutes to submit the second question. So today what I'm going to be doing is I'm going to be looking at some practice problems. This one here that I have is from 2017. I'll leave a link in the description below to where you can get practice problems from all years that the AP Statistics exam has been going, and I highly recommend that you practice those. Alright, let's take a look at this question. The manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup up with a soft drink from the beverage fountain instead of filling up the cup with water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled up the cup with a soft drink from the beverage fountain. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill up the cup with a soft drink from the beverage fountain. Alright, so it's a pretty standard question about confidence intervals, and we need to make sure that we really get this question, right? So when we're doing a confidence interval, the very first thing we need to do is have our assumptions. So the first assumption we need to make is about having a random sample. Because if you don't say that we have a random sample, then it's open to interpretation. So somebody could say, since you didn't say we had a random sample, there could be bias in the study, therefore making your conclusion invalid. So that's why it's important that we have assumptions. So the way I like to write it is I say, we have a random sample, but you have to be specific in statistics, otherwise you will not get the credit, especially on the exam. So what do we have a random sample of? Well, let's look in the question. We have a sample of customers who asked for a water cup when placing an order. So just copy that exactly. Who asked for a water cup when placing an order? The second assumption we have to make is about the population size. So here we say that we have a random sample of 80 customers. However, there is a rule in statistics that our population needs to be at least 10 times the size of our sample in order for our results to be significant. So the way we write that is the population of customers who asked for a water cup is at least 10 times n, which is 80 times 10, which is 800. Next, we need to look at normality. So normality means that we can assume that we have to do some work in order to show that our distribution is normal. And then only we can calculate our confidence interval. So how we do normality is we do something called the NP check. What that is basically doing is we are multiplying the sample size by the proportion, and we are ensuring that it is greater than 10. So it is written as n times p. In this case, n is the sample size. Looking back, it's right here, 80 customers. And the proportion we're actually not given in this question. We are only given the sample proportion. So this is why a lot of people will say it's called n times p hat. P hat just means the proportion. So this is the proportion of customers that took a soft drink when in reality they were supposed to get water. So this is 23 out of 80. This is given in the question. So go ahead and find the decimal equivalent of 23 over 80 in your calculator, which is 0.2875. Alright, perfect. So now we multiply 80 by 0.2875 which is 23, and it is greater than or equal to 10, so we say check. Next, we have to do n times 1 minus p hat, which is 80 times 0.2875, or 1 minus 0.2875. Let's go ahead and undo that. 80 times 1 minus 0.2875. So let's go ahead and find what this is equal to. 0.2875. This is 57, which is greater than or equal to 10. And now we have to write a conclusion statement. So we can write, I'm just going to type it out. So we say, since both values are at least 10, the sampling distribution is approximately normal. So this is how you would write your assumptions. Next, we need to look into calculations because we have to calculate our confidence interval. So let's look at that. Again, make sure you denote where you are actually doing your calculations. Okay, so our calculations are here. So it asks us to construct a 95% confidence interval. So recall that our confidence interval formula is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n, where p hat is our proportion, z star is our z critical value, which I'll talk about, and n is our sample size. So we found from our step up here that p hat is 0.2875. So we have 0.2875 plus or minus z star, we'll get to z star, what that means, times the square root of 0.2875 times 1 minus 0.2875 over 80. Okay, so now we need to talk about what z star is. So what z star is we are taking our 95% confidence interval and we are looking to find the standardized value of it. So here's a little bit of a graph that'll help you understand. So when we say something has a 95% confidence interval, that means we're saying we're taking this middle segment and we're trying to find a confidence interval from this value right here to this value right here, and we're creating an interval. So now what we want to find is we want to find this value right here called z star, where all of this shaded in region is to the left of the value. And the way we do that is we do something called inverse norm. So the way we write that is we do inverse norm, and now it's asking us to find a 95% confidence interval. So this is 0.95 and this is 0.025. Please review your notes if you do not know why this is, or please drop a comment because this is kind of basic knowledge and make sure you understand this. So it's 0.975 because we add 0.95 with 0.025, and then standard normal curve, mean of 0, standard deviation of 1. Put this in your calculator. This is going to give you 1.96. So now all we have to do is take out this right here. We can plug in that value for z star, 1.96. And now I'm going to change my color here. I'm going to go ahead and get my confidence interval, which is, you can either put this into your calculator or you can do stat test, and then you can scroll all the way down to 1 prop zint, hit calculate, and you get your confidence interval, which is 0.1883 to 3869. No, 38667. Okay? So that is our confidence interval, but we're not done yet. We have to make our conclusion statement. There's 3 parts to every problem. There's always a conclusion statement. All right, conclusion. Luckily, this conclusion is not too complicated. So the way you write it is you just have to say, we are 95% confident that the true proportion of, remember, go back to your problem and look at what you're finding of. Look at what you're trying to find. So the proportion of all customers who, having asked for a water cup, will fill up the cup with a soft drink. Customers that fill up their cup with a soft drink when they ask for a cup of water. Oh, that's cut off. Alright. Here. Yeah, here we go. Is between, and now you write the bounds of your confidence interval, 0.1883 and 0.3867. Okay? So, we are 95% confident that the true proportion of customers that fill up their cup with a soft drink when they ask for a water cup is between 0.1883 and 0.3867. So, let's go ahead and review. This is the correct solution to question A. And please drop a comment below if you want me to show you guys how to do section B, walk through it in the next video, hopefully. But we have our assumptions. We started with these assumptions. We said that we have a random sample. We made sure that the population was at least 10 times the sample size. We proved our normality using our NP check. And we made a statement saying, since both are at least 10, the sampling distribution is approximately normal. Then we moved into our calculations. We wrote the formula for a confidence interval. Then we found z star using inverse norm. We plugged in all our values. We found our confidence interval. Finally, in our conclusion, we made our statement saying that we are 95% confident that the true proportion of customers that fill up their cup with a soft drink is between 0.1883 and 0.3867. This is the correct solution to 2017 AP Statistics, question 2A. Thank you so much for watching, and I hope to see you again soon.